Hi. Many of you have already done some sort of scientific experiment in your past science classes. And what I'd like to go over is a little bit of review of a controlled experiment or experimental design. You can go ahead and reference Chapter 1, Section 3 in your textbook, and that will give you some more information and a little bit more detail as well as some supplemental examples that you might need in terms of understanding the whole picture. One of the things about scientists is we like to ask questions, and the questions are often going to be based on things that we observe. So we observe, we ponder, we ask a question. For example, in this question here, I want to know about these plants. I want to know whether or not does fertilizer actually help plant height? In other words, if I were to apply fertilizer to a plant, will that make the plant grow taller? And I just said what we have here is a hypothesis. So I want to know a cause and effect. So if I fertilize a plant, or if fertilizer is added to the plant, then the result will be that that plant will grow taller. So what I have now are bases for what type of data I'm going to collect. I'm going to obviously collect any sort of plant height, so I can measure that, often in centimeters. And I'm going to basically add fertilizer, which often is a combination of nitrogen, phosphorus, and potassium. So I have formulated a hypothesis, which hopefully will then be able to give me the results of a cause and an effect of whether or not fertilizer is going to be an additional factor of adding plant height. In this particular experiment, we also have to be attentive in terms of the control group. The control group and the experimental group are going to be exactly the same with one exception, and that the experimental group is going to receive the fertilizer. Often is going to be dissolved in water. If I'm looking at all these plants up here, I don't want to experiment on all three plants unless my experiment is designed that way. I just want to know the effects of fertilizer on plant height. So I'm just going to pick one of these plants, and let's go ahead and stay with the purple salvia. That means I'm not going to select these other plants, because it may well be that these subsequent plants that I have crossed out would respond differently to the fertilizer. So I'm going to use the same species for both the control group and the experimental group. I'm going to use the same volume of liquid. I'm going to have the same temperature in the room that both of these are going to be kept. And I'm obviously going to have more than one plant in case one dies, in case one doesn't respond. So say I'm going to have 10 plants each. And I'm going to hopefully find 10 plants which start off at about the same height. So the control group is going to allow me to compare how the fertilizer affects plant growth. The data gathering, I can gather that the data often is going to be numerical. Okay, so it's going to be quantifiable. I can also have a side chart in terms of the color, whether it might appear greener, or the flowers, how many flowers might show up after a couple of days. I'm going to then organize these into data tables. And that's one of the things that we'll be doing in class, is how to organize data in data tables. So we're going to gather the data, and obviously because I'm looking at plant growth, I'm going to need some time in here. I'm going to allow my experiment to run 60 days. So in that 60 days, I should have enough data to allow me to make some type of conclusion over the effects of fertilizer on plant height. So as you begin to see, we have the variables that we've talked about in class. We can begin to see how we can formulate the data that we've gathered and make a visual of that. The dependent and independent variable, remember the y is going to be the dependent variable on the y-axis, and the x-axis is going to contain the independent variable. In this case, what are we looking at? Fertilizer and plant height. So we're seeing how the dependent, which is the responding factor, we're measuring in terms of height. So in essence, we're measuring how well this plant responds based on height, which is a quantifiable data. So we can go ahead and have here our height, and let's go ahead and use a measurement that we are familiar with, and that is going to be centimeters. So now we have the height. The next part we have to figure out is that of the independent variable. It's a little tricky here because we have two sets of data. We have the control group data, And let's say we had 10 plants, we want to take the average. And we have the fertilizer or the experimental group and that data. And again, we're going to take the average each time we measure them. And I'm going to go ahead and I'm going to measure my data every 5 days. So we now have the idea that we're measuring in days, and we have 5, 10, 15, all the way up to 60 days. And we have a unique, the scale is going to be set so that each is a set factor. So now in that point here, we have both of them in terms of our data gathered. We could use colors in terms of the color for one versus the color for the other, and then make our data and determine whether or not does fertilizer affect any sort of plant height. Okay, so the controlled variables, as I stated earlier, are things which are going to be kept the same. The controlled variables, remember, we're going to keep the volume the same, the temp the same, the number of days the experiment goes on the same, what time of day we measure, the species of plant. So all of those are ways in which we are controlling the experiment so that the reality of fertilizer being the manipulated variable. Fertilizer is what we want to know, right? We want to know if fertilizer affects plant growth, so we keep everything else the same. Once that is done, then we can present our data. Often in presenting our data, we'll go ahead and have a section in a write-up report, and that data will include the tables, it'll include the graph that we make, it'll include whether or not our hypothesis was supported, it will include whether or not that hypothesis was rejected, and whether or not we have to go ahead and make another experiment and maybe redesign it. The conclusions will often use our data to support any sort of statement made. Lastly, and most importantly, is that our experiment, the procedures, we'll work on the procedures later on, but this test can be retested and retested and the similar results obtained no matter what. Okay, so that's just an overview. Chapter 1, Section 3 can give you some more details on that. Be attentive, ask questions in class if you have any questions. All right? Have a good one.